Now we want to formalize those English sentences and translate them, all of them, to CNF. So let's start with formalization. Let's introduce our predicates. Let's say I choose the predicate Rx for to represent that X can read. I choose another predicate EX for X being educated. What else? I choose DX. This is D for X being a dolphin, because the exercise is about dolphins. And yeah, and there is something about being intelligent. I of X represents that I is intelligent. And now we can now start to formalize the sentences. The first sentence is a universally quantified sentence, right? It's about everyone. So we are talking about everyone. For all X, everyone who can read is educated. So basically, if X can read, then X is educated. Rx implies EX. Okay, let me translate it to CNF on the fly. Actually, we don't have to do too much. We just need to remove the implication and replace it with disjunction. Of course, we also negate Rx. So what we get is for all X, not Rx or EX. This is in CNF. You cannot see any existential quantifiers. The quantifier for X is in the front, in the prefixum, and the scope is quantifier free and is in CNF. Great. And this is a clause, actually. This is our first clause. Let's continue. Dolphins are not educated. Well, it's a good question if this is a universally quantified or existentially quantified statement. I think you can also feel that this is about this is a generic statement about every dolphin. So yeah, so this starts with the universal quantifier for all X, and of course we must filter that everything to dolphins. So for all X, dx implies, so if X is dolphin, then it's not educated. Negation EX. It's so easy to translate this formula to CNF. Again, we remove the implication, sorry, and negate the left-hand side. So what we get is for all X, not DX or not EX, and this is actually a clause. The third formula, the third sentence is the following: there exist intelligent dolphins. Of course, this formula has to start with an existential quantifier, like exist X, and it's about intelligent dolphins. So basically, X should be a dolphin, first of all, and it should be intelligent. So basically, this formula says there exists someone or something in the universe which is a dolphin and intelligent. There exists at least one intelligent dolphin. Okay, this is not in CNF because CNF must not contain any existential quantifier. We must remove it. How? By scholemization. Since the existential quantifier is located at the very beginning of the formula, there are no formulas before it, no preceding, there are no preceding quantifiers. This is what I wanted to say. We can remove it by introducing a new Skolem constant and substitute it into all occurrences of X, and then we can remove the quantifier. Of course, the huge parenthesis is not needed anymore, and this is what we get. This is in CNF. A CNF that consists of two clauses, two unit clauses. The first clause is DC, contains one single literal. The other unit clause is IC. Okay, last sentence. There exist such intelligent beings who cannot read. Of course, we must use an existential quantifier, exists X, and then intelligent beings. So X, of course, is supposed to be intelligent and cannot read. So not R of X. Exists X, IX, and not RX. We can translate this formula to CNF easily, but there is a very important detail. When we scholemize this quantifier out, we have to introduce a new Scholem constant, it's a brand new one. You cannot choose C because C is already in the formula. You must choose a brand new Scholem constant, for instance, D. And of course, I remove the quantifier, and here we are. We generated two new clauses. I would like to mention that sometimes, for the sake of simplifying things, to make our clauses as transparent as possible, we don't even write the universal quantifiers, because, you know, if you find a variable in the formula, you can immediately know that it is universally quantified. There is no other choice. There are no other quantifiers. Only universal quantifiers can be included in CNFs. So basically, we can do this trick. I mean, this is not a real simplification. It just makes easier for us to read our clauses. Yeah, so later on we will do the same. We will formalize statements, we will translate them to CNF, and we will make them as simple as possible, because later, when learning about the resolution algorithm again, we will work on such clause sets.